Hi, welcome to a2zknowledge.com. So today we are going to discuss about Apache Spark. This is going to be an completely an introduction video for Spark. And before getting into this video, I have shared my playlist link in the description box where you can get all the big data videos. And then I have shared my LinkedIn URL and the Instagram URL in the description box. So in case if you want to contact me or you want to follow me, you can do via that. And if you haven't subscribed my channel, please do subscribe my channel after watching this video. Okay, we can get into the video. So Apache Spark, it's so in big data. So we have so many solutions for the data problems. So very familiar solutions like you might have heard about Hadoop or you are already experienced with Hadoop. So similar to that, we have something called Spark. Okay, so Spark is also a data processing framework and that comes under big data. So what is the prerequisite for me to jump into Spark? So that is the very first thing we have to see. So prerequisite with respect to Spark, so you need to be aware of some of the Hadoop components. For example, HDFS, MapReduce. MapReduce very basics is fine, but HDFS, the complete stuff of HDFS you are supposed to know. And then Hive. Okay, so these three components are like very important for you to learn before you start Spark. So I will tell you the reason. So why Spark is sorry Hadoop. These three components is required as a prerequisite for me to learn Spark. See, Hadoop and Spark are two frameworks, two solutions for data problems. And you may ask me like, why should I have to learn Hadoop and then Spark? Directly, I can learn Spark, right? Okay, so they are two different components, and there is no mandatory dependency should be get created. There is no such thing. They can be installed separately. You can work on these two components completely in an independent way. But in the real time, the dependency has been created. So Spark and Hadoop are tightly coupled in the real time. But just for learning purpose, yeah, you can go ahead and learn just Spark without having Hadoop knowledge. But in real time, as I said, it is tightly coupled. So on this point, I will explain more in upcoming the same video in upcoming topics. Okay. So this is the first thing. You may ask me like why in Hadoop we have so many other components, right? Like Scoop, Uzi, HBase, and Ambari. So you haven't added that in the list. So those things are not required for you to learn Spark. Okay, they are optional, but these three things is mandatory for you to learn before you start Spark. And next, with respect to Spark, so you have to be very good in any one programming language. It could be like Java or Scala or Python. Okay, so Spark supports these three languages. So you can be like you if you are very new to programming language, then just pick any one of these language and you have to brush up the basics and the core concepts. That would be fine. And then Linux. So Linux is very much important for any big data frameworks you go, and even programming languages also. Like even I have a video called Hadoop framework, which was my previous video. I have explained like what uh, programming languages and what are all the stuff as a prerequisite for the entire big data framework. So Linux is very much important, and any one programming language, and SQL. So SQL SQL knowledge is also required. So not very core or depth. So basics is very much enough. Like DML, DCL, and DDL commands are very much enough. And before all these, so before these two prerequisite, you need to be very clear on what is the problem big data is all about and how we are giving solution, and what are all the data components we do have under big data, and how this big data came into picture. So the entire history and use the need and things about big data you need to know. So I have a video called what is big data. It's like almost 40 minutes video. I recommend you to watch that video first. So that is going to be the very first video of my big data playlist, which we call it as big data demo or what is big data, whatever you can call it as. So that will be my first video. Just please have a look on what exactly big data. And then I have the prerequisite I'm just explaining you here, like Hadoop stuffs, and these Hadoop stuff, and then programming language Linux and SQL. So once you are very good on these prerequisite, you are good to start with Spark. Okay, and I haven't answered you that in real time how Spark is tightly coupled with Hadoop. Okay, so that question I will answer you in some time. So if you take Spark, so we need to know what all the components we do have in the Spark framework. So if you see in Hadoop framework, there is a diagram, right? HDFS, map, reduce, hive, pig, scoop, Uzi. So something like that. In Spark also we have a framework diagram. So I will explain you that. The very first thing is Spark. Okay, so this is your engine in Spark framework. This is your engine. The remaining components got means which got built on top of the Spark SQL. So Spark SQL, that it's like a SQL query engine, but it's not exactly like Hive, but it's a SQL query engine through which there is some very good structured APIs are provided so that your data can be in, you can have a structured name value pairs. So the more into Spark SQL, I'll be explaining you in the upcoming videos. It's like you are just writing a program, and your data will be in the format of, you can give names, column names for your data in the program itself, and then you can able to uh, uh, do any kind of transformation in very easy way, not like 100 200 lines of code. It will be very less. You can do any kind of transformation in just 2 to 3 lines you can do. So that way of rich APIs was provided by Spark SQL. And Spark SQL is also used to connect Hive in Hadoop, so you can read the data from Hive and you can do all the transformation via Spark SQL. So Spark SQL is again used to connect with Hive to retrieve the data from Hive and run it on top of Spark. So this point I will explain you later. And then you have something called Spark Streaming. Spark Streaming. Okay, so if you take like Spark, it's completely a data processing framework. So in data processing, you have two types of data processing: batch processing and stream processing. So batch processing means your input is already stored in a file or in a database, on top of which you are doing some kind of an processing and you are getting the output. So this is called a batch processing. Okay, so I'm giving a quick one-liner description of what is batch and stream processing. But if you want to have a detailed content about these two, then I have a video link in the description box: batch process versus stream process. You can watch that video. But I will be telling you here. So batch processing is something the data is already there and you are doing a processing. And the stream processing is something like the data is coming in live. That means it's not get stored anywhere in a storage system. Your data is it's coming in live from the application, and you are processing the data in the live itself, and then you are giving the output. For example, I'm just going to an supermarket and I'm just swipe my debit card in the swipe machine. So immediately I'm in getting an SMS saying that your transaction has been done and this much amount has been debited. So that means the time when I swipe my card, immediately the data is going in live. In the bank side, it's getting processed in live, and then I'm getting the output, and then only my transaction details are getting stored. Right. So here the stream processing will not wait for, I will wait until some 10 to 20 records comes into my picture. So it's not like that. So any transaction that happens, whether it's one transaction at a time or 10 transaction at a time, it will immediately process. It won't wait saying that at least 10 to 20 members has to swipe their card at the same time and then only I can process. No, it's not in that case. So in batch processing, data will be get stored first and then you will do process. So in stream processing, so in live you will be doing the process and then only your data will be get stored. Okay, so Spark supports both batch processing and stream processing. So in a single framework you can do both the things. But if you take before Spark, Hadoop is only for batch processing. You can't do stream processing in Hadoop. So before Spark entered into picture, there was a technology called Storm. So Storm is used for stream processing and Hadoop is used for batch processing, whereas in Spark we can able to do both. So whereas if you go for Storm, it's only for streaming, there is no batch processing, and in Hadoop only batch, there is no stream processing, but Spark we can do both. And then next, so there is a component called mlib in your Spark, which is for machine learning libraries, where you can do all machine learning activities. And there is something called GraphX. So this is a graph-related data store where you can write the APIs gives you an very easier way to do any kind of graph related data processing. Like if you go for LinkedIn and Facebook, you will see mutual connections and mutual friends. The person A is also interested on the thing, there is a relationship. You are finding the interest between the persons, right? The person A, this is a person who knows by A also knows by B, so there is a relationship is building in the graph format, the nodes, edges, vertex kind of stuff. So this is especially created for such use cases. So as a data engineer, especially as a big data engineer, so as a big data engineer, so we need to be very good in this three components only. So mlib and graphics is highly optional for data engineers to learn. So these three are very important for the data engineers should know, and especially big data engineers. And the priority goes like this. So priority, Spark batch, Spark SQL, and then Spark streaming. Okay, so Spark streaming, comparative, if you compare Spark SQL and Spark compared to these two, the Spark streaming is used very less. Okay, it's there, but compared to this, Spark streaming will be very less. But the priority of your learning, the roadmap will be like this. You have to learn Spark Batch and then Spark SQL, and then you can go for Spark streaming. Or once you complete Spark Batch, directly you can go for Spark streaming also if you have a requirement to learn fast. Means you don't have Spark SQL in your project, but you have Spark streaming, then you can go ahead with Spark streaming after learning Spark batch. So it's not like you have to go only through Spark SQL. So it's not like that. Okay, fine. So here I have just given you the one-liner description of these, but these three components, Spark batch, Spark SQL, and Spark streaming. So we'll be seeing more detail in upcoming video. Okay, so now I'll go for the next one. Okay, so now, like, if you see in the Spark, right? So I will just uh, have the framework diagram once again. So Spark SQL, and then Spark streaming, mlib, and then graphics. Okay, so categorize these components into data layers. Okay, so data layers means if you go for any data projects, there will be some different data layers, right? So data storage, like data storage, data processing, data scheduler, so data visualization, and then data testing. So you'll be having data pipeline. Data pipeline is something used to transfer the data from one place to another place. So we have these many varieties in the data projects, right? So any data projects you go as a very basic stuff, what we need is we need a storage layer, and we need a processing layer, and we need a pipeline layer which used to transfer the data from one place to another, and we need a visualization layer. In some project we will not have visualization, but we do have processing and storage for sure we used to have. So any framework that you learn, that you are going to learn in big data, make sure there is one step that you have to do is categorize the components what you see in the framework, whatever you are learning, into these layers. We have to do a categorization just for our own understanding and for learning purpose, and this will help you to give an solution when there is a problem comes into picture. So if you take storage, so we don't have a storage part, right? So there is no storage part in Spark. So if you take Spark and Spark SQL, Spark streaming, they are completely into processing, data processing. And mlib is also into data processing, but it comes under analytics. And graphics is also for data processing. So on the whole, the entire Spark is comes under only data processing. But if you take Hadoop, right? So we do have HDFS, HBase, Hive, and Pig, and then Woozy, Flume, like we do have Zookeeper, MapReduce, etc. So if people comes from a big Hadoop framework, so that will be the very first framework that people used to work and people used to learn. So when people come from the Hadoop framework, they'll be having a mindset like this. I will tell you what's the mindset. See, if you take Hadoop, HDFS and HBase is for storage. So in Hadoop we do have storage, and Hive, Pig, and MapReduce for data processing. So Hadoop comes under data processing, and Woozy is for scheduler. Yeah, we do have scheduler here, and Flume and scoop is used to retrieve the data from one place to another place from then some different technology to Hadoop. So for migrating the data, we use Flume and Scoop. So this comes under data pipeline. So that means if you see like Hadoop is covering more than 4 data layers, so people used to think all Hadoop, all big data frameworks also covers these many layers, but that is not the true fact. See, each framework like Hadoop and the Hadoop frameworks has been developed by different people and different group of community and different companies and different individuals. So Hive was contributed by Facebook, Pig was contributed by Yahoo, HDFS and MapReduce was invented by Duck Cutting, who is father of Hadoop. So this things and all invented by different people. And if you see Spark again invented by a different set of community members. So it's not like Hadoop has all the layers and Spark should also have all the layers by default. No, it's not like that. So that's a different framework and this is a different framework. And something like that, we have some other framework as well in the market that also in big data. If take Storm. So Storm comes under only data processing again. Storm doesn't have its own storage or its own query processing and all. It's just a framework and that do only data processing. So your mindset has to be in that way. So it's like all the framework will not comes under all the data layers. So you have to first of all have that in your mind. Fine. So now the question comes. So that means in Spark, how can I store the data? Or in Spark, how can I schedule the stuff? Or in Spark, like how can I migrate the data from one place to another place? So you will be having these many questions. So I'll give answer for those questions. So if you take first data storage, okay, so Spark by default, the framework doesn't support any storage, but still you can integrate some of the other storage technologies with your Spark. So that is possible. So when you take storage, two important things, database and then file system. So database, it's a DB, and file system is all about like you have file system right in your Windows. The Windows file system name is NTFS, New Technology File System, and the Linux file system name is EXT. In Mac we use Mac file system. So these file systems are called standalone file system, and in file system we have distributed file system. So in file system you have two types. So standalone file system and then distributed file system. So standalone file system example Windows file system, EXT, Mac file system, etc. Distributed file system, so HDFS. Yeah, we already aware of HDFS, so I add HDFS. And in Amazon there is a object store called S3. Like HDFS in AWS, they use S3. So I can add S3 also or any other distributed file systems. And in database, two types. So RDBMS and then NoSQLs. NoSQLs or the modern database in big data world, DB is all, when you say DB, it's a NoSQL. Okay. RDBM is the old one. So RDBMS like Oracle, MySQL, DB2, etc. NoSQLs like the top three NoSQLs in big data, HBase. HBase is a NoSQL that comes with your Hadoop, right? And there is a database called Cassandra, MongoDB. So Cassandra and MongoDB are two like independent products, so they are not tightly coupled with Hadoop, but still you want to integrate with Hadoop also, yeah, you can do. So if you see data storage in DB, Spark can be connected with any RDBMS and Spark can be connected with any NoSQL database. And Spark can run on top of standalone file system as well and distributed file system as well. So if you take Spark, right? So Spark is something like it runs on HDFS, it runs on S3. So the data will be get distributed if the data gets stored in a distributed file system. So you have 10 Windows machine and you are trying to store 1 GB data in very first Windows machine, it will not be get distributed, right? Even though they are created as a cluster, still the nature of file system in Windows will not distribute the data. But if you take HDFS or S3, there is a 10 S3 mission or 10 S3 HD, sorry, 10 HDFS mission. If whereas in one node you load some 1 GB data, the data will be get distributed across the nodes, and on top of which you write some Spark program will be get distributed. So you can ask a question here. In that case, when I run Spark on top of Windows, you are saying like Spark can sit on top of Windows, Linux directly. without any distributed file system, how come Spark will do a distributed processing? So Spark has a talent, even though it runs on a standalone file system, still Spark can able to read the data from the standalone file system, and then it will distribute the data in the memory, and then it will do the processing. Okay, so that is where we call it as in-memory processing. Spark supports in-memory processing. Okay, but I will tell you that later. So Spark in memory, I will tell you that part later. So here storage part we have completed. So Spark supports all type of storage. So now I'm going to explain you the other data layers, how Spark is giving support on scheduler or pipeline. So that part I will be explaining you. And now I'm going to explain you one more thing, like how Spark is tightly coupled, or is there a possibility to integrate Spark with Hadoop framework, and if so, why we are doing that. So I will tell you that. So for that I need to give you the diagrams of the framework diagrams of both the Spark and HDFS Hadoop. So first let me have the Hadoop framework diagram. So HDFS map reduce and hive pick scoop Uzi and flume mahout hbase. So we do have few more components, but these are the kind of a solid components which we do have, and we call this as Hadoop framework. Yeah, as I told you, we have few more components as well. So let me put some dot like this. So, but this is considered to be a complete Hadoop framework as a base. And now let me go for Spark here, Spark and Spark SQL and Spark Streaming, mlib, and then graphics. Okay. Now, if you see here, uh, I will tell you some kind of a kind of a real quick story here. See, when Hadoop was there and people migrated their existing technology, the data from the existing technology to Hadoop, and they were enjoying the performance of the data processing and storage and everything. And within a year or two, like Spark entered into picture after Hadoop, and then like companies started explaining to the client saying that Spark is 10x faster than Hadoop, so we can migrate the things from Hadoop to Spark so that we can have more performance. But initially client was not that much okay to migrate immediately. The reason is that the generation gap between Hadoop and Spark is very less. It's just an year, like 1 year or 2 year, within that we got a new technology. So clients were saying like, so just now we migrated everything to Hadoop and the performance what I'm seeing is really good, then why should I have to migrate to Spark? And the companies have explained that it is 10x faster, we'll be getting more cost savings, and then the performance will be really high, the downtime is less, some blah blah things they have explained. It's a proven one, but still they have explained, and the client have asked one question. Okay, so I accept everything, I agree Spark is faster, everything is fine, but here the problem here what client was raised to us is, see, we do currently we have written all our programs and the job data processing programs in Hive, Pig, and some in MapReduce. Right. So that means, do I need to convert all these Hive scripts, Pig scripts, and the Java code of MapReduce to something else in Spark, or directly Hive scripts will work on Spark, or directly Pig will work on Spark? So the question they have asked. So initially, when Spark entered into picture, so the companies have said like, no, you can't directly run Hive scripts on Spark. You can't directly run Pig on top of Spark. So you have to convert to the logics into some new language what Spark supports, new syntax. So then client said, no, we can't do it then. So just now migrated everything to Hadoop. So now you want me to convert it to Spark, and again I have to hire some new resource, or I have to make my existing resource to learn what is Spark, the new syntax, new programs. So that will take again 1 or 2 years to migrate from Hadoop to Spark. So it's not that much gonna be the easiest part. So they are not agreed to migrate it to Spark. So this made the Spark contributors like the sad thing, right? So the Spark contributors, they can't able to sell their product in the market. The reason is, even though it's faster than Hadoop, the need is not required as of now. See, imagine Spark has entered into picture after 10 years after Hadoop, then people will consider, even though it has new syntax, migration, everything is okay. But it's just 1 or 2 years Spark entered into picture, and you want me to migrate everything to a new syntax and new coding from Hadoop, then it's not going to be the good part because I'm enjoying the performance in Hadoop itself. So this made the Hadoop Spark contributors, they couldn't sell the product. So what they have done is, so they have just seen what are all the components they are using lot for data processing in Hadoop. So Spark has enabled the connectivity to Hive, Pig, Scoop, Oozie, Flume, Mahout, HBase, and everything, even HDFS. So that means now Spark can integrate with all the components in your Hadoop. Okay, and that means what is means in Hadoop component, which particular part is replacement of Spark. Okay, so this map produce is like the Spark is replacement of MapReduce. So now initially MapReduce was the only engine in Hadoop. Now Spark is another engine. So all these components initially were running on top of MapReduce engine. Now these components will run on top of Spark engine. Simple. So you don't want to convert your existing Hive or Pig scripts to the new syntax. It can run as is on top of Spark, but maybe for the new requirement, you can start doing some coding with Spark. Or directly you can again write Hive queries also, that's fine. It will run on top of Spark. So why I'm coming means I'm two things about the topic. What I explained you is for two things. One is we need to know what are all the components that you can integrate in the Hadoop components that you can integrate with Spark. Okay, and we need to know what is the replacement of in Hadoop, which part can replace Spark, or Spark is replacement of which particular component in Hadoop. Yeah, so we come to know that MapReduce can be replaced by Spark. Now the next thing is like few years back from now, one of my friend, like he told me that I'm working in Spark and Hadoop is dead, completely Hadoop is dead, so Spark is everything hereafter. So then I asked him a question, can you explain me the tech stack that whatever you are using in your Spark project? So my question was, what is the storage layer? He said HDFS. So what, so the data is coming from the source, right? So what is your source? He said RDBMS. Okay, which tool you are using to bring the data from RDBMS to your Spark? So he said HDFS is used as a storage layer, and I bring the data from RDBMS to HDFS via Scoop. Scoop is a component which we have in Hadoop, which will migrate the data from RDBMS to Hadoop and Hadoop to RDBMS. So he said Scoop. Then what is the scheduler that you are using? He said Oozie. Oozie is again the scheduler part of Hadoop. Then he said the NoSQL database is HBase. So then I asked him a question. So you said you are working on Spark project, but when I ask for the tech stack, so far you haven't said Spark. You are saying HDFS, Scoop, Oozie. You are saying like all the Hadoop components, and then finally you are saying that your engine is Spark, and then that's called a Spark project. So in that case, how come Hadoop is dead? So you use all the component of Hadoop in your Spark project, and then you say Hadoop is dead. So the statement is wrong. So he should say in this way: MapReduce is dead, or MapReduce went for the corner where Spark replaced it. So that is a correct statement. So Hadoop is not dead. When you say Hadoop, the whole thing is what Hadoop. Okay, Hadoop framework. So the whole thing is Hadoop framework. So still people in the real time, so this is how the dependency got created. So the very first question I raised, right? So I can learn Spark directly. Why should I have to learn Hadoop? So this is the answer. So for learning perspective, there is no dependency. You can learn Spark just like that from the day one without learning Hadoop. But in real time, Hadoop and Spark were tightly coupled. Okay, so you can see Hadoop projects in real time. The statement is important. Just please listen. In real time, you can see any big data projects without Spark. You can see only Hadoop. You will see such projects, but you will never see Spark projects or Spark infrastructure or a Spark cluster without Hadoop. You will not see. Okay, so in any cluster you go, any infrastructure, any cluster setups you go, Hadoop will be installed first, and then on top of it they will install Spark. So Hadoop and Spark by default that comes with your cluster, and the dependency got created that they are tightly coupled. The reason is for Spark, the underlying storage, people always use HDFS, and that means you are using Hadoop system, right? So on top of it we have Hadoop and sorry Spark, in which like Spark reads the data from HDFS Hadoop, and then it will do the processing. So as I told you, you cannot see only Spark without Hadoop in the real time, but you can see in reverse. There will be a project still going on only Hadoop without Spark, that you can see, but you cannot see the other way. So this way, the real time, in real time, the dependency has been created. So that gives that is why I'm saying that you need to know at least HDFS, MapReduce, and Hive before learning Spark. Okay, so now we are discussing all about the integrations. So Spark can be connected with Hadoop for 100% with all the components, but not with MapReduce, because Spark is a replacement of MapReduce. So there is no need or use cases to connect MapReduce and Spark. It's not required at all. So now Spark and in future some other system can come and sit in the engine. So Hadoop turned as a platform. It incorporates all other engines into Hadoop, and that way Hadoop has been got mutated. Okay, and how about integrating Spark with any other big data technologies other than Hadoop? So in big data, you have 10,000 plus technologies. Even in the Hadoop framework video, I told all big data framework, not only Hadoop, not only Spark. If you go for any big data frameworks, one big data framework can connect with another big data framework for sure, 100%. Okay, so Spark can be connected to any big data components like any NoSQL database or any data pipelines like Flume, Scoop, Kafka, or any other cluster manager like Zookeeper or any other systems. It can be connected for sure. Now, integration outside big data. How about Spark can connect with some other technology outside big data? So most of the technologies existing, demanded existing technologies, traditional demanding technologies like any RDBMS, you can connect with Spark. Any ETL tools like Informatica or Ab Initio, you can still able to connect, or any visualization tools like Tableau, ClickView, MicroStrategy, you can connect. And even you can connect Spark with any AWS components and Google Cloud components and Azure components, you can able to connect for sure. So like I can say Spark or Hadoop can be connected with the existing technologies that's outside the world of big data. 90 to 95 percentage of technologies can be connected. Any mainframe technologies, testing technologies, it can be connected. But more specific to the component, if you ask me, if I'm not aware, I have to check and I have to research, and then only I can able to say. But if you ask me the question like how about Spark and Hadoop can connect with any other big data technology, I can say 100% blindly, I can say yes, it is possible. You can connect with any big data technologies. Okay, so the integration part we have discussed, and like we have discussed Hadoop framework diagram and the integration and the layers. Okay, now we can move on to like into Spark like slowly. Right. So now the very first question. So what is Spark? So I already explained you. Spark is a data processing technology which will do both batch processing, stream processing, and also for analytics. Right. So next, what programming language does Spark support? So Spark supports three programming languages: Java. So Scala is very first. Priority goes to Scala, Java, and then Python. And for analytics, we use R. Okay, so Scala, Java, Python, they are like people are using evenly like these three languages. Scala, Java, and Python is like used very like 50-50 percentage it used. So it's not like Scala is used a lot and Java is very less and Python is overused, and it's not like that. So people across the projects, if you see like 10 Spark project out of which 3 project will be in Java, 3 will be in Python, and 4 will be in Scala. So it will be like that actually. So if you are going to learn Spark, you have to pick any one language. You can go ahead with Scala or Java or Python. Anything is fine. So the language which you are trying to means which you feel which is very easy, you can pick that and you can start learning. And one more important thing is when you start looking for job change, and in the job description, you will see like we need Spark with Java developer and Spark with Scala developer, Spark with Python developer. So some people used to understand this wrongly and they will not attend the interview. So imagine I'm Spark with Scala developer initially. So that means I'm just seeing a JD in which they have given Spark with Python. So I'm thinking, so I've been in Spark for 3 years or 4 years. I worked with Scala only, but the next means the company to which I'm going for an interview, they said we need Spark with Python. So that means it's not like you should not get panic or something like that. I've seen some people will say like I'm not interested. The reason is they're asking for Spark with Python, but I'm aware of Spark with Scala. So don't do that mistake. Please attend the interview. So you are not going for Python developer. You are going for Spark developer, and they are asking for Python with Spark. So you already aware of Scala with Spark is completely fine. Okay, just go to the interview and just say like you have been done in Scala, but you can still code in Python and with Spark. See, the syntax wise, if you see in Spark, all these three languages will have similar syntaxes only. Okay, so when it comes to Spark syntaxes in this three language, the syntaxes will be very similar. It will be very easy, and especially Scala and Python, the programming way you see it will be more similar actually. So don't do that. Okay, people are doing that repeatedly. I'm trying to convince them by saying this. Don't do that. See, your agenda is, your aim is to be a Spark developer. Whether you use Spark with Java, Spark with Scala, Spark with Python is completely fine. Just attend the interview. Okay, so the next thing is general prerequisite of Spark. As I told you, you need to know Linux, you need to know SQL, and then any one programming language, as I told you, right? And then the next thing, uh, like daemon process in Spark. Daemon process is background process. So you are installing Spark. So once you install Spark in Linux or Windows, when you install just a Spark, so what are all the background process will be there? So when we say if you install any big data framework in your machine, so there will be some background process running, which will be the backbone, and that will actually controls your entire cluster, whether it's single node or multi node. It will control the entire cluster. So you might have heard about name node, data node, job tracker, resource manager, node manager, alias task tracker in your Hadoop, right? So similar to that, we have daemon process in Spark. So there is two daemon process in Spark: master and then worker. So when you install only Spark, and then when you check for the process, you will see master and worker. But an upcoming video, I will explain you the installation of Spark, and then I will show you all this process. So daemon process, which is called the background process, and the deployment mode. Deployment modes. So Spark can be deployed in in major three types. So standalone cluster or standalone. And then, so standalone. So what is mean by standalone? So people will think standalone means installing Spark in single node. No, that is wrong. So installing just only the Spark in single node or multi-node, but you are installing only Spark. So that is called standalone in single node or standalone cluster. Okay, so only Spark. You can ask me, we are going to install only Spark, right? So then why you are calling it a standalone? You can call it a Spark node or Spark cluster. No, so we can install Spark with Hadoop also. Okay, so there is a difference. So installing only Spark is different, and installing Spark with Hadoop is different. So when you install only Spark in your entire cluster, there is one technology stack called Spark, and that only running in your cluster means it is standalone. Whether it is single node or multi-node doesn't matter. Standalone means installing the Spark only with multi-node or single node. So installing Spark with Hadoop is called yarn mode of deployment. So in Hadoop, there is one more component called yarn, which allows having more than one engine on top of your Hadoop. So MapReduce was the only engine initially, and Hadoop will not support any other engine on top of Hadoop other than MapReduce. So in Hadoop, then they have introduced something called yarn, yet another resource negotiator, which will allow other engines like MapReduce. Like I told you, I showed you in the previous diagram, right? Like MapReduce, there is Spark, and tomorrow there can be one more engine can come and sit on top of your Hadoop. So that was allowed by this yarn. So if I'm developing a new engine and I want this engine to be deployed on top of Hadoop, then I have to write a source code to integrate that with yarn. Means as the creator of the framework, I have to do that. Okay, so when you install Spark with Hadoop, it's called yarn deployment. So when in an interview, if they call you, means if they ask you, right, have you done Spark yarn deployment, that means they're asking whether you have installed Spark with Hadoop or just Spark only. Just Spark means standalone, but in real time there is no standalone. It's completely yarn. That means Spark installed on top of Hadoop, yarn mode of deployment only. And there is one more called Mesos. So this is not that much used in the real time, but still similar to yarn, there is something called a mesos. Yarn and mesos are like cluster managers. Okay, so mesos is not part of Hadoop, it's not part of Spark, it's a different cluster manager. So it can be used in mesos cluster manager as well. So we have discussed about deployment mode. Now the important thing about Spark is in memory computation. What is in memory? So in memory means, so you have RAM. So RAM is called memory, right? So in your machine you have hard disk, cache, and RAM. So the recently accessed records and files will be stored in the cache, so that whenever you try to open it again, it will be very faster, right? So that means, so the data in memory will be very faster for your processing, read and all, but the data that comes from disk will take time. So in-memory processing is all about the data will be get distributed in the memory of Spark in each node in the RAM, and then the processing will happen. But the in-memory data processing in detail I will explain you later. But in-memory is one of the biggest advantage, like why Spark is faster than Hadoop, because in-memory processing. MapReduce supports in-memory, but it's not very much big extent actually. So that's why in Hadoop we can't use in-memory processing with MapReduce. Okay, it supports, there is a concept which supports in MapReduce called a distributed cache, but it's not that much efficient as we think, like how we have in Spark. Okay, so and then like next point, so Spark REPL. So what is REPL? Read, evaluate, print loop. REPL is all about having a command line shell to for the testing. For example, I can tell you in this way. In command prompt, if you just type Python enter, you will get a Python shell, right? And in MySQL, when you type MySQL in command prompt, you will be getting MySQL shell. So this shell is called REPL, read, evaluate, print loop. So we are not aware of what is REPL, but we are using it in our daily life, right? So whenever any technology you use the shell, then that technology supports REPL. So Oracle has a REPL, Python has a REPL, Scala has a REPL, Java from 1.9 it has a REPL. So REPL is used for testing the piece of line of code rather than writing the complete code in IDEs like IntelliJ or Eclipse and building that as a jar file. So just for testing the piece of code, why should I have to write a whole project and convert that as a jar file and run it in the cluster? So I have to do all this stuff. So REPL is widely used for testing purpose, right? So in Python also you use REPL first to test the logic, and then you will deploy that as a script or a file, right? Similar to that, Spark supports REPL. So Spark has two REPL. The first REPL is Spark shell. So Spark shell is all about it. It invokes Scala internally, and there is one more REPL for Python called PySpark. So if you enter PySpark, it will go for Python shell for Spark, and if you enter Spark shell, it gets into Scala shell for Spark. Okay, so there is no shell for Java in Spark. Only two REPL, PySpark and Spark shell. So, but Java as a code, you can write it as a file and you can build it as a jar, that is supported in Spark. But just for a shell, it provides only two REPL, Spark shell and PySpark. And this we call it as a REPL. Okay. So the next point, 8. Okay. So three important APIs that Spark has. So all your programming syntax will come under these three APIs. So it means either you start with Scala or Java or Python. So for example, you pick Java or Scala or Python. So your syntax and the way of code will be comes under these three important APIs. So the APIs are RDD, data frames, and dataset. So on the whole, these three are and these three concepts are like it's distributed and fault tolerant. So what these three APIs will do, it will distribute the code what you are writing will come under any one of these three. So that means these three on the whole, what it will do, it will process your data in distributed way, and then it will process your data on a parallel mode, and the fault tolerance will be provided for your data. So all these three APIs, the basic characteristic is this. And apart from that, RDD will be like you have to be more code specific, and whereas in data frame, the for your data you can give a structure in the coding like column names and rows and columns, you can give it in that way, and the syntaxes will be very easy. And then the data set is an extension of data frame, and data frame is an extension of RDD with added new components. It's like generation 1, generation 2, generation 3. So that way it will be. But as a detailed explanation, I will be giving you in upcoming videos. So I'll make a separate video for RDD, data frame, and dataset alone. Okay, so on the whole, your coding syntaxes will be get categorized into these three APIs only. Next, so transformations and actions. So all your programs, that the coding whatever you are writing, you pick Scala and you use data frame or dataset or RDD. So then your programs, the syntaxes will be categorized into two. Okay, so first you have to start with the coding. You choose one language and you choose one API, and within that API there is one more categorization of your syntax: transformation and actions. So transformations means anything that you transform the data. For example, map is a transformation, and you want to do a group by is a transformation, and then you have to do a sort, and then you have to do a filter, etc. So all these are transformations. So action, so you want to do some count operation, or you want to show the output, or you have to save the file. Um, Save as text file, etc. So these are some keywords that you will be seeing in your Spark. So how can I differentiate these syntaxes or transformation and these are an action? That is based on the experience you will get, but by seeing the name you can able to say this, these all transformations. So show is not a transformation, it's an action, right? But short and group is a transformation, it's not the action, right? So this transformation and action is how your codings will be get categorized into. Okay, and based on the transformation and action, I want to tell you one more important thing: lazy evaluation. What is lazy evaluation? Okay, now imagine you are writing some 100 lines of code. Okay, so I'm doing map, and then output of map, on top of it I'm applying and filter, and on top of it I'm applying and group operation, and on top of it I'm applying and sort operation, etc. It's going in this way. Okay, now and finally you are not doing anything, and the last operation will be like again you are doing group, and then that's all, your code is completed. You are trying to run this code. So you have done a map, filter, group, sort, etc., and then like 99 line of your code is transformation. But what is the use of it? Finally, you are not getting any output. You are not printing. You are not doing any print statement or show statement or save as file state. Nothing. You are doing nothing. Only you are doing transformation. So Spark executes all these and finally comes to know you are not performing any action. So then what is, so Spark will ask you, a Spark compiler will ask you, so then why I have compiled all this? I've just spent my entire resource from the cluster. I utilized RAM, I utilized CPU, and finally there is nothing for me to perform the as an action. I did all the transformation, but what is the use of it? Right. So that means Spark started working something called lazy evaluation. That means at end you have to call an action, so it could be count or show or any other actions. So imagine I'm giving save as text file. So when you compile this code, Spark will not see all these first. Spark will first see is there an action in your code. So once it finds the action only, the compilation will start from bottom to top, and that is where we call it as lazy evaluation. That means some people used to do only transformation just for testing purpose, but without performing the action. And that means Spark will say like, why should I have to spend my time when there is no action? Why should I have to run only the transformation? What is the use? So Spark will do lazy evaluation only when it finds the action, then only the compilation will get start. So the bottom to top approach is what we call it as a lazy evaluation. So you have to have some action and then only your transformation will be get started. So that is we call it as a Spark lazy evaluation. So whatever we have discussed so far, so I will just give you an overview. Like we discussed Spark framework diagram, and then Spark integrations and data layers, and Spark integrations with Hadoop, and Spark integrations with outside the world of big data. And then what is Spark, and we discussed about in memory, and we discussed about daemons in Spark, and we discussed about Spark REPL, and then deployment modes, and the three APIs: RDD, data frame, and data set, and transformation and action, and lazy evaluation. So for this particular introduction video, whatever we have discussed is very wide enough. So in upcoming videos I'll be entering more deeper into the architecture and the practical, the installation and everything. So this will be your complete introduction video about Spark. So this will be wide enough. So thanks for watching a2zknowledge.com. If you really like this video, please do subscribe my channel. We do a lot of tech videos in two languages, English and Tamil. So I have already shared my LinkedIn and Instagram URL in the description box. If you want to contact me or you want to follow me, you can do via that. And I have shared my big data playlist, and the remaining, like I have Scala videos also, that playlist also I have shared. And a link which I told you that I will share is batch processing and stream processing, so that link also is there in the description box. So thanks for watching. Please do support us. Please share this in your LinkedIn and to your friends and colleagues. Thanks for watching.